Alright, moving on to more antiderivative examples, we first need to look at what's called the differential rule, which basically means the antiderivative of dx. Now, let's think about this for a second. We had a rule where we had the derivative of x, right? And it was just 1. This is kind of the reverse, basically. We're finding the antiderivative of something with respect to x, but there's nothing there. Well, in fact, the answer is going to be x plus c, because the derivative of x plus c is 1 dx with respect to x. And so basically the way I explain this is there's a 1 there for antiderivative of dx that we don't see. And now you can see that the derivative of x is 1, right? And so the antiderivative of 1 dx is x plus c. So that's why it's called the differential rule, because there's a 1 coefficient there that you can't see. Next rule we're going to learn real quick is the reverse power rule. So basically, when you do the normal power rule, you take the exponent, you move it out to the, make it the coefficient, you subtract 1. Well, in fact, we do the opposite, of course, for the antiderivative. We're going to increase the this exponent by 1 because it's the derivative, and then we're going to be dividing by that exponent plus 1. Instead of multiplying by n minus 1, we'll be instead of multiplying by n, we'll be dividing by n plus 1. And then don't forget the plus c, because when we take the derivative of this, we'll get the original back. Okay, this one looks a little weird at first, but once you do some examples, you're going to see exactly why it works. But just to reiterate, the antiderivative of x to the n is x to the n plus 1 divided by n plus 1. So for an example, real quick, antiderivative of x cubed would be x to the 4th divided by 4. 3 plus 1 is 4, and you just divide by that number. You're going to see why that works, because when you take the derivative of that, the 4 would come down here, it would cancel with that 4 we have now, and then it would become a 3, right? And the 4's would cancel, and you get x cubed back, which was your original function. So without further ado, let's get to an example. That's just the rule explained verbally. And for some reason it's not going down. Here we go. So what is the antiderivative of x to the 5th? Again, you might need to work a little bit on these symbols, but the more you do it, the better you'll get at it. Evaluate just means figure out, and this is actually saying we want to figure out the antiderivative of x to the 5th. So x to the 5th is the derivative function, right? We want to figure out the original function we basically started with to get there to x to the 5th. So this is going to be the reverse power rule. Make sure it's in power form, and of course x to the 5th is in form. Just looks just like a power. We're going to take the antiderivative of that, so we're going to increase this power by 1 and divide by whatever that plus 1 is. So we're ultimately going to be dividing by 6. So we get x to the 6 plus x to the 6 divided by 6 plus c. Keep reiterating that. Do not forget your plus c, because the derivative of c is 0. C could be any number. Okay, when we simplify, instead of instead of x6 over 6, we usually write that as a coefficient. So we'll write 1 over 6 times x to the 6th plus c. Now we want to check our work by taking the derivative of this. We should get x to the 5th back, our original, or at least the function we started with. So this is the derivative of this is the original. So if we take the derivative of 1/6 x to the 6, move the 6 down, so 6 times 1, 6, which just becomes 1, right? And 1 times, and then we would decrease this by 1 using the original power rule, become 5, and that gives us x to the 5th, which was the original function we started with, which confirms what we just showed. But I want to show you why we do a plus c, and I want to show you the graphical representation of this. Okay, so here's the graph of 1/6 x to the 6th plus c. I used a. You could use any constant. Actually, yeah, let me go ahead and change that to c so you don't get confused. So here we have plus c. When we move this slider around, what happens to the graph? Nothing about the slope, right? Just its position. If you were to draw any tangent line on this graph, it'd be the same regardless of your c value. It just shifts it up and down. And so for that reason, we take the derivative of c, it goes away, and you just get the x to the 5th function, which looks like this. And so that's, again, why we have a plus c, because it just shifts the graph. It doesn't change the slope of the graph at a given point.